So guys, in exercises 6 and 7, only 6 is listed. Find the lengths of the diagonals of rectangle JKLM. There's no picture, right? But it does tell us that JL equals 3x plus 4 and KM equals 4x minus 1. What do you guys think we need to do?
Solve the equation.
What equation?
4x minus 1 equals 3x plus 4.
Okay. Marcos brings up a good point. 4x minus 1 equals 3x plus 4. Now, we can't just set these equal to each other. Why are they equal to each other?
Start explaining how to
Yep.
solve this. Because if you subtract 3x.
No. Why is JL equal to KM?
Oh, because they're diagonals.
Why are they diagonals?
Because.
Doesn't say that they're diagonals. It just tells us that we have a rectangle, JKLM.
Because it's JL and KM instead of just JK or LM.
Good. It's the order of the letters. So if we were to draw a rectangle, right? J, K, L, M, label this J, this K, this L, this M. Remember, whenever your letters are in order, you have to follow that order around your rectangle. So JK would be a side. JL is a diagonal. To go from J to L, you're jumping across. It's two non-consecutive vertexes. Same thing with KM. It's a diagonal. Okay? So we know that JL must be a diagonal and KM must be a diagonal. That's your first piece of information. The second thing, what do we know about the diagonals of a rectangle? They're not parallel. Yes, they're congruent. The diagonals of a rectangle are congruent. Diagonals of rectangle are congruent. So therefore, now we can say that 4x minus 1 equals 3x plus 4. Perfect.
I don't know if it's just my screen, but we can't see your screen share. It says air server.
I think that just happened. I'm going to try to fix it.
Okay.
Is it back?
Yeah.
Okay. So now we set 4x minus 1 equal to 3x plus 4. If you just set them equal to each other because you were like, I think, don't be that person, okay? Sometimes questions are going to be worded differently and you're not going to just be able to set them equal to each other. One might be half of the other one. Make sure you know where it's coming from. Okay. Once we set these equal to each other, now we just need to solve this. This is the easy part. Marco said he subtracted 3x from both sides. I agree. Let's subtract 3x. We're going to get x minus 1 equals 4. And then we just add 1 to both sides. And we get x equals 5. Are we done?
No.
Why not?
We still have to add, we still have to use the new variable that we found on JL and KM.
Very good. Does it matter which one we plug it in for?
Yeah.
No. Okay. Since these diagonals are the same, right? We should get the same answer regardless of which one we plug it in for. So let's plug it into JL. 3x plus 4. We plug in x equals 5. JL equals 3 times 5 plus 4. We're going to get that JL equals 15 plus 4, which is 19. Five properties of trapezoids and kites. So we've got two new figures that we're going to learn about today. Okay, they're both quadrilaterals. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. The non-parallel sides are called the legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. So remember, the bases are parallel. The legs do not have to be parallel. And your base angles are the two angles located on both sides of a base. Why are trapezoids not parallelograms? Noah?
Because they don't have two pairs of congruent sides.
Not necessarily congruent. What's a parallelogram?
Oh, parallel.
Parallel, okay? Do you see how the legs, they don't have to be parallel, okay? That's the reason a trapezoid is not a parallelogram. It's because of those two legs. They don't necessarily have to be parallel, okay? If they are parallel, then we've got a parallelogram. But if they're not, then it's a trapezoid. Okay.
Just the word. Okay.
We also have something called an isosceles trapezoid. If the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. That means that your two legs are congruent and you've still got two parallel bases.
Wait, can you go to the slide before?
Mm-hmm.
You can go back.
So we talked about isosceles triangles before, right? Where two of the legs were congruent. Same thing for an isosceles trapezoid. Both of the legs are congruent. Okay. There are some theorems related to trapezoids, okay? So there's an isosceles trapezoid base angle theorem. It states if a trapezoid is isosceles, then each pair of base angles is congruent. So if trapezoid ABCD is isosceles, then A is congruent to D, angle A is congruent to angle D, and angle B is congruent to angle C. So I'm just going to highlight them so we see it. B is congruent to C, and A is congruent to D. The isosceles trapezoid base angles converse. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So that says if angle A and angle D are congruent, or if B and C are congruent, then the trapezoid is an isosceles trapezoid. So we can make the conclusion about the line segment AB being congruent to CD, okay? We would make the conclusion that AB is congruent to CD. That is the converse. That side is congruent to that side. And there's one more theorem related to isosceles trapezoids. Remember, these are all isosceles trapezoids, not regular trapezoids. An isosceles trapezoid diagonals theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So that would mean that AC is congruent to BD. Those two diagonals are congruent. What other figure has congruent diagonals? Who remembers?
Square.
A square. What else?
Rectangle.
A rectangle. Very good. Okay. Another thing you guys need to know about trapezoids is something called a midsegment. The midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs, okay? So remember how triangles, we would draw the midsegment? It would connect two midpoints of any of the two sides. Same thing for a trapezoid, only it's the midsegment of the legs. If we were to draw the midsegment between the bases, this is not a midsegment, okay? Not a midsegment. It has to be the midsegment, has to go between the two legs, the midpoint of the two legs. Okay. There's a theorem related to the midsegment, and it says that the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So the parallel portion is pretty self-explanatory, okay? Every midsegment that you draw, it's gonna look like it's parallel to the actual trapezoid, okay? So we know that this is parallel. So go ahead and put a parallel mark on it. And now the other piece of information is that it tells us that it's also 1/2 the sum of the two bases. So let's label this B1 and let's label the bottom one B2 for base 1 and base 2. So XY is equal to base 1 plus base 2 divided by 2. It's 1/2 the sum, or okay. Now a kite. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. Exactly two pairs of congruent consecutive sides. So ABCD is an example of a kite. Where the two consecutive sides are congruent. And also it kind of looks like a kite, right?
Mm-hmm.
We could draw a little tail here. It would be a nice kite. Okay. Which of these two angles need to be congruent?
A and C.
See, that's where those are the two that are not congruent.
Oh, no.
Okay? B and D.
B and D.
Good. B is going to be congruent to D. I like to think about it, they have the exact same sides, right? So they should be congruent. A has two different sides than C does. Do you guys see that? A has two different sides than C does. B and D have the same sides. Okay? So they have to be congruent. All right. Properties of kites. So if a quadrilateral is a kite, then its diagonals are perpendicular. Okay? So AC that diagonal across the entire kite is going to be perpendicular to BD. So this will be a 90-degree angle in there. And the other theorem related to kites is that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And it's going to be the pair of angles that share both of the congruent sides. Do you see how B and D, one side of B has the single congruence mark, the other side has the double, right? That one's going to be congruent to D, which also has the same two sides, okay? Angle A and angle C are not congruent, okay? A and C are not congruent. So if we jump back a slide, some examples. Find the measure of angle A. Well, first off, we learned about trapezoids and we learned about kites. Is this a trapezoid or a kite?
Trapezoid.
Trapezoid, very good. So let's label it a trapezoid. And we also learned about special types of trapezoids. We learned about an isosceles trapezoid. Is this an isosceles trapezoid?
Yes,
Why?
because the two sides are congruent.
Yeah, but we call those sides something. What do we call them? The legs.
Legs.
Very good. The legs are congruent. So the legs are congruent, therefore it's isosceles. I don't think I will ever remember how to spell isosceles.
Isn't it ISOCE?
Is that right?
I think so.
Hopefully. Who knows? I certainly don't. Okay. Isosceles trapezoids. Remember, the base angles are congruent. So what other angle is going to be congruent to C?
B.
It's not B. It's not A. It's going to be D. Yes. D is going to have to be 100 degrees, okay? Because these two are base angles. Okay? So that means A and B are also base angles. So they must be congruent, okay? Yes, they each have to be 80. We'll get to that. So these are also base angles. And they both must be equal to 80. Who knows why they're equal to 80?
Because AD is a straight line, which is a straight angle, which is 180.
Yes. So since these two are parallel, AB is parallel to CD, in an isosceles triangle, actually in any trapezoid, okay, the two angles that are not base angles must add up to 180 degrees. So these two add up to 180, and so do the ones that are not base angles. Have to add up to 180 degrees. Because it's basically two parallel lines cut by a transversal, okay? Where BC is our transversal and also AD is our transversal. Perfect, okay? So the measure of, hold on, it's not letting me zoom. Angle A is just 80 degrees. Example 2. Okay. Trapezoid or kite?
Trapezoid,
Trapezoid. Why is it a trapezoid?
because it has the two, one pair of parallel sides.
Has one set of parallel sides. Good. Is it isosceles?
Yes.
Yep. So what does angle E have to be?
49.
Uh-huh. And angle F?
131.
Good. 131. And angle G? 131. Okay? Remember, your base angles, which are these two that lie on the same base, must be equal. And these two, which lie on the same base, must be equal. So the measure of angle F equals 131 degrees. And how we got the 131, for those of you that are confused, you just did angle, the measure of angle E plus the measure of angle F must equal 180 degrees. Because those two lie on the same leg, okay? The two angles that lie on the same base are going to be equivalent for an isosceles trapezoid. The two that lie on the same leg are going to add up to 180. Okay.
Okay.
You good?
Wait, can you go back to the first thing that was?
KB equals 21.9 and MF equals 32.7. Find FB. Well, these are diagonals, right? What do we know about the diagonals of a trapezoid? You can go back in your notes.
They're equal.
They're equal? Go back in your notes.
They're congruent.
Yes, they are congruent. I was just kidding. Okay, so MF is 32.7 and FB must be what? Well, let's figure it out. How do you guys think we would find FB?
Half of 32.7, so you can divide by 2.
So for parallelograms, they cut each other in half, right? For trapezoids, they don't necessarily cut each other in half. If we know that MB is 32.7, right? I'm sorry, MF is 32.7. What else has to be 32.7?
KJ.
KJ. So we know that KJ equals 32.7. Now if KF equals 21.9, I'm sorry, KB, what is JB? It's not 1/2 of that. Good. It's going to be 32.7 minus 21.9. It's going to be 32.7 minus 21.9. When we subtract these, this is going to be a 1, 17. We'll get 8, and then 0, 10.8. So this little section has to be 10.8, and this little section FB also needs to be 10.8.